Hey everyone, this is Taser at 3 a.m. Today we're going to look at a really interesting and old CVE. This is a cross-domain token exposure vulnerability in Ollama, and yes, it affects the latest version too. So how did I find this? Well, I was going through recent CVEs and security advisories, and I came across this one on Hunter. The original researchers, Mohammed Ben-Heli and Patrick Ventizello from Futzing Labs, discovered that Ollama has a critical flaw in how it handles authentication. The vulnerability is simple but devastating. When you try to pull a model, Ollama blindly trusts whatever authentication URL the server tells it to use. This means an attacker can redirect your credentials to their own server. Let me show you exactly how this works. First, let me prove this works on the latest version. I'm running Ollama directly from source using go run main, go serve. As you can see, I just did a git pull to make sure we have the absolutely latest code. This isn't some old outdated version. This is fresh from the main branch. Ollama is now running and ready to accept requests. Let's do a quick health check to make sure everything is working. Perfect. Ollama is responding. Now I'm going to start our malicious registry server. This is a Python Flask server I wrote that simulates an attacker's infrastructure. The server is now running on port 8080 and ready to capture tokens. Before we run the exploit, let me explain exactly what's happening under the hood. When you run Ollama pull with a model URL, Ollama connects to that registry. The registry responds with a 401 unauthorized status, which is normal. It's asking for authentication. But here's the critical part. That 401 response includes a www authenticate header with a realm URL. This realm tells Ollama where to send its authentication token. Normally, this realm should point back to the same registry, but Ollama doesn't verify this. It just blindly follows whatever URL is in that header. So our malicious server responds with, "Hey Ollama, send your token to our registry.ollama.ai, the real official registry." And Ollama goes, "Sure, no problem." It generates a valid token, signed with your private ed to 5519 key, scupped for the official Ollama registry, and sends it. But wait, our malicious server intercepted that request. We now have a valid token for the victim's account on the real Ollama registry. This is the core of the vulnerability. No validation, complete trust. Instant credential theft. Now you might be wondering about HTTPS and encryption. Ollama normally uses HTTPS for registry connections, which means we'd need a valid SSL certificate. For testing purposes, we have two options. Either add our self-signed certificate to the system keychain, or use HTTP mode with the insecure flag. I'll be using the no SSL flag on our server, and the insecure flag in our API request. This is just for demonstration. In a real attack, the attacker would have a proper domain with valid SSL. The key thing to understand is that the vulnerability isn't about breaking encryption. It's about trust. Ollama trusts the realm URL without validating it belongs to the same domain. Let me quickly show you what our malicious server can do. We have several endpoints. The V2 endpoints handle the fake registry API. This is what Ollama talks to when pulling models. The token capture endpoint is where we receive the stolen credentials. We can view all captured tokens through the tokens endpoint. There's also a health check and usage information. The server has colorful output so we can easily see what's happening, incoming requests, the www authenticate header we're sending, and most importantly, when we successfully capture a token. Now let's actually run the exploit. I'm triggering the pull request now. Watch the server terminal. And there it is. Token captured successfully. Let's break down what just happened in the console. First, we see the incoming request from Ollama trying to access our fake registry. The path shows it's looking for a manifest file. This is standard registry protocol. Our server responds with 401 unauthorized and includes the malicious www authenticate header. You can see the realm URL pointing to our capture endpoint. Ollama receives this and thinks, okay, I need to authenticate. It generates a token and sends it to the realm URL. And boom, we capture it. Look at that authorization header. That's an ed to 5519 signed token, generated by the victim's Ollama instance using their private key. This token contains their identity, the scope of access, and a valid signature. We've essentially stolen their session. The token is automatically saved to our stolen_tokens.json file for later use. Now here's where it gets really scary. Let me restart the server with the steal official flag. This flag changes our behavior. Instead of capturing tokens for our fake registry, we redirect Ollama to authenticate with the real registry.ollama.ai. Let me trigger the exploit again. And look at this. The realm URL now points to our registry.ollama.ai. Ollama generates a token for the official Ollama registry, but sends it through our server. We've just captured a token that's valid for the real Ollama infrastructure. This is the difference between a proof of concept and an actual attack. With this token, an attacker could access the victim's private models, push malicious models under their name, or do anything the victim is authorized to do on the registry. The victim has no idea this happened. They just tried to pull a model and it failed. Meanwhile, their credentials are in the attacker's hands. This is the real severity of the vulnerability. Getting a token SCUP for our regist or y.ollama.ai means full access to the victim's account. Private company models. Accessible. Want to push a backdoor AI model under the victim's trusted identity? Possible. This turns a simple, wrong URL mistake into complete account compromise. And remember, this works on the latest version of Ollama. So that's CVE, a cross-domain token exposure vulnerability that affects all versions of Ollama. The fix is simple. Validate that the realm URL belongs to the same domain as the registry you're connecting to. The Ollama team has PR addressing this. Until then, be very careful about what model URLs you pull. Stick to official models and trusted sources. I want to give credit to the original researchers, Mohammed Ben-Heli and Patrick Ventuzello from Futsing Labs, who discovered and reported this vulnerability through Hunter. The proof of concept code is available on my GitHub, link in the description. Please use it responsibly for educational and authorized testing only. If you found this video helpful, please like and subscribe. It really helps the channel grow. Thanks for watching, stay safe, and I'll see you in the next one. Peace.